If we recall from chapter 9 that all atoms like to have 8 electrons around them, we're going to call that the octet. So there's an octet rule, and that is all atoms except hydrogen. That's going to be, we're going to have to treat hydrogen separately in all cases. All atoms need 8 electrons to be happy. Hydrogen, because hydrogen is on the first floor of the periodic table, hydrogen can only have a maximum of 2 electrons because it only has the one s orbital available to it. So don't worry about that. But hydrogen needs 2 electrons around it to be happy. So hydrogen would like to look like helium, and every other atom would like to look like the noble gas configuration. So again, if we are looking at a molecule, we're going to have to treat hydrogen separately. And I'm just going to give us some examples of some molecules, and we're going to see that electrons are shared. Okay, so here electrons are going to be written as dots. Okay, so instead of writing arrows for electrons, we'll represent electrons as dots, which is more common, especially in biology. And we're going to see that electrons occur in pairs. So if we ever have a dot all by itself, then that means something's wrong. Okay. And the atoms are going to share electrons so that everything has 8. Another thing we have to care about here are the valence electrons. So we talked about that in chapter 9. Valence electrons are in the outermost shell. Now, if we look at the periodic table, it's going to be very easy to tell how many valence electrons there are in every atom. So hydrogen is the only non-metal that we're going to be concerned about. Hydrogen is in column 1, and some periodic tables have the number 1 written above here, a 1 or a Roman number. But so hydrogen has 1 valence electron. So we could write hydrogen like this. Okay. Then if we go over to above carbon, there's a number 4 in the periodic table. So carbon and silicon would be in this group 4. Above the nitrogen column is group 5, so nitrogen and phosphorus each have 5 valence electrons. Oxygen and sulfur each have 6 valence electrons around them. And fluorine, chlorine, bromine, and iodine each have 7 valence electrons around them. And again, we are not going to care about neon, argon, krypton, and xenon, because these are the noble gases and they don't do anything. Okay. So your book is going to show that carbon, we could put 4 valence electrons like this. Nitrogen, I know I just said that they have to be paired up. That's when they're in a compound. So we could represent nitrogen like that. Oxygen, we really don't care where the dots are here. And fluorine, bromine, and iodine typically they have 7 valence electrons around. Okay. This picture will help us later when we're pretending that we're building molecules. Okay. And a bond means that electrons are shared between atoms. So I'm going to take a water molecule, so we're going to have a hydrogen, and actually 2 hydrogens and 1 oxygen. So the H2O molecule, if I write oxygen's oxygen's in group 6, so it has 6 electrons around it, and then each hydrogen has 1 valence electron around it. So if I write that, then this is what the water molecule would look like. And we're going to see that shared electrons are going to draw as a line. Okay. So that, we'll see a lot about that. 1 line equals 2 shared electrons. And 1 line, we're going to call that a single bond. And if we look back at this molecule, everyone's happy now because oxygen now has 2, 4, 6, 8 electrons around it, and each hydrogen has 1, 2 electrons around it.